What is nutrition? That seems like such a simple question, but as you're going to find out in a couple minutes, it really isn't. And what is nutrient density and how does that relate to nutrition? Those are the topics I'm going to have a look at in this program. We're also going to have a look at how you measure nutrition. Can a gardener actually do that? If you have 2 carrots that you've grown, can you tell which one is more nutritious? There are some gardeners out there who think you can do that. Now, over the years, I found that there's a lot of misinformation about nutrition and healthy food. And that's one of the reasons I wrote this book, Food Science for Gardeners. I found that there really isn't a great book out there on this topic. Now, there's some great textbooks, but they cover a lot of things that gardeners and homeowners aren't really that interested in. So this book is good for gardeners as well as people who buy their food. It's not really a how-to grow book. It's a what is nutrition? How do we make sure we're eating safe food? And then once we get the food in the house, how do we preserve it and cook it so that we maintain that high nutritional level? What is nutritious food? And what's the difference between nutritious food and nutrient density? What do these terms really mean? I'm sure you have some sense as to what nutritious food is, but if you try to actually define it, you're going to find it's very difficult to come up with a definition that we can all agree on. Let's have a look at some of the reasons for this and understand nutrition a lot better. One of the things to understand is that the science of nutrition is still a very young science compared to many of the other sciences. If we look at the discovery of vitamins, the first one discovered was vitamin B1, and that was in 1910. And then in the 20s and 30s, more and more of the vitamins were discovered, and vitamin B12 wasn't discovered until 1948. Now, I know that seems like a long time ago, but you have to remember that these dates represent the day that the vitamin molecule was actually described. It doesn't mean we knew anything about the vitamin. So even though in 1948 we knew about vitamin B12, we didn't know its role in the body, we didn't know how much we need, we didn't know how important it was to our health, and so on. All of those things came much later, and it's only been in the last 20, 25 years where we really understand the role of vitamins. Now compare that to Isaac Newton's theory of gravity, which was written up in 1687. Compared to sciences like physics and chemistry and biology, nutrition is a very new science. Why do I bother mentioning that? Well, it's really important to understand because I think the general population thinks that we know all about nutrition. I mean, if you listen to the headlines, you're told that, right? You're constantly told what you should eat and what you should not eat and how much of this you need and how much of that you need. Well, it turns out that in many cases, we still won't have enough information to make those conclusions. Now, the scientists know they don't have the right information. They're still studying a lot of this. But newspapers don't like uncertainty. They want to go with a headline that grabs your attention. So they're telling you eat more blueberries. I'll come back to blueberries in a few minutes. But understand that a lot of the information you're given is based on some of the science we know, but we don't know it all yet. We're guessing at a lot of these things. Now, we do know some things about nutrition. Vitamins are important. A lot of these vitamins we can't make in our bodies, and so we have to eat them as part of our food source. Now, there are other categories of important molecules. The other ones I'm sure you're familiar with are the minerals, calcium, magnesium, iron, and so on. Now, it's interesting that those minerals are exactly the same minerals that plants need. When we talk about plant fertilizer, we're talking about these minerals. In fact, the list of essential minerals for plants is identical to the list of minerals that we need as humans. In fact, every living organism on Earth needs these same minerals. Now, we may need them in slightly different amounts, but everything living needs iron, it needs phosphorus, it needs potassium and nitrogen. Let me just take one example here. Let's look at phosphorus. Phosphorus is a key element in DNA. It's the backbone of DNA. We couldn't have it without it. And every living organism has DNA or RNA, which is a different type of DNA, essentially the same molecule. Nothing can live without phosphorus. We all need it. Another molecule that you probably haven't heard about is called ATP. This is like a little battery that gets recharged all the time. It's an energy source. It's this molecule that travels around your body, and whenever a reaction needs some energy, it releases that energy to that reaction. It makes things happen in our bodies. Then ATP goes off and gets recharged, gets more energy from things like sugars and carbohydrates, and then goes off in the body and causes other reaction. In plants, they also use ATP. Plants, it gets recharged by photosynthesis. That's energy the plant gets from the sunlight. Now, if you look at the ATP, you have that P at the end, that stands for phosphorus. This molecule couldn't possibly exist without phosphorus. All right, so we know these minerals are essential, and we have to get those in our diets, just like plants. Another group of molecules you probably heard about are proteins and amino acids. Proteins are large molecules, and they're made up of a chain of amino acids. Protein could have thousands of amino acids in it. And these proteins, they carry out most reactions in your body. I mean, you just couldn't function without proteins. The amino acids are made up of a collection of 20 different amino acids. For humans, 9 of these are essential. What that means is that those 9 we have to get in our diet. Our bodies are not able to make them out of other molecules. Scientists are understanding proteins fairly well, and we've documented a lot of different proteins, and we know how they work and what their function is. They're absolutely critical for life. So if you don't get those 9 essential amino acids, you're not living. It's as simple as that. So these are important in our diet. All right, so the molecules I've described so far are the things you probably know about, and that's important in our nutrition. But scientists have started to find other molecules that are also important. They've started to call these phytonutrients. So phyto means plants, and nutrients means it's a molecule that we need in our diet. So phytonutrients are things that we need to eat. And those molecules, once they're in our bodies, do all kinds of good things. Well, it turns out that we think there's somewhere around 25,000 of these phytonutrients. Now compare that to the other molecules I just described, the vitamins, the minerals, and the amino acids. Okay, now we've got another 25,000 compounds. Now, one example of these phytonutrients is something called anthocyanin. This is an antioxidant. You may have heard that term. Antioxidants are molecules that zoom around our bodies, and they basically deactivate harmful chemicals. These are harmful chemicals that are produced in our body. It's a side reaction from just living. They aren't necessarily molecules that we're getting from the environment that are harming us. They're molecules we actually produce, and the antioxidants go around and get rid of them. We're fairly sure that these antioxidants reduce the chance of cancer, but the science on that is still a bit fuzzy. Like, we're pretty sure that's what's happening. And so, of course, the headlines are out there and says, well, eat blueberries. Why? Well, blueberries have a lot of anthocyanin in them. That's an antioxidant, and we're pretty sure antioxidants are good for us. But notice that I said pretty sure. We're not certain yet. We don't know for sure that eating blueberries will reduce the chance of cancer. There's a lot of unknowns here, and the headlines in newspapers and news outlets and online news are much more positive about these things than the real science that we know. Now, what does all this mean? Well, it means that there are some 25,000 important molecules for our diet. So a nutritious food, well, should have all 25,000, right? or at least a lot of them, and should have them in quantities that will help us. So you might ask the question, well, which vegetable has the most of these phytonutrients? Well, we don't really know that because we haven't measured all 25,000 molecules in the food we eat. In most cases, we've only looked at a few of the things. We know the minerals, we know the amino acid, and we know the vitamin, and we know a few of the antioxidants and a few phytonutrients, but we haven't looked at most of them. This is still very unknown. So let's go back to the original question. What is nutritious food? Well, it turns out that we don't have a definition for that. Scientists can't agree on what is nutritious food. Now, you could argue the fact that any food that has some of these useful molecules is nutritious, but then pretty much every food that's not processed is nutritious. Something like even white sugar, which is highly processed and pretty much consists of only sugar. That's still nutritious because that sugar is an energy source for us, and our bodies do need some sugar in our diet. So you could almost argue that even white sugar is nutritious food. So that's not really helping us much with the definition. Clearly, fruits and vegetables are better because they have more types of nutritious compounds in them than, say, white sugar. So what is nutrient density? Well, that's a term that's being thrown around a lot these days, and what it really means is that we want to quantify how nutritious a food is. Think of it as a number. This is the nutritious food number, okay? And we're going to call that nutrient density. It's some number that comes along that quantifies the food we're eating. So we might have two food items in front of us, and one might have a value of 90 and the other one will have a value of 150. Well, the one with 150 is a better food, is more nutritious. So that's what nutrient density means. Now, have you ever seen a nutrient density number? Have you ever gone to a grocery store and picked up a produce or picked up a packaged food and looked at the label, and in big letters it says the nutrient density number is 140? No, you've never seen this because it doesn't actually exist. Now, scientists are trying to figure out, well, how do we define this number and how do we come up with this number, because it would be a very useful number for everybody to have, but we don't have it yet. And it's actually a very complicated thing to get. And I'd like to go through a few examples because they'll give you really good insight into what nutrition is. So let's have a look at the orange. I mean, we all know oranges are nutritious. They're very healthy for us. They're important for us. Now, one of the reasons that oranges are important for us is that they contain a lot of vitamin C. I'm sure you've heard that. So let's ask a simple question. Are oranges a good source of vitamin C? And the answer is yes, they have a fairly good amount, but there are a lot of other things that also have similar amounts of vitamin C, or even maybe more vitamin C. Some of those include things like guava, kiwi, peppers, broccoli, and Brussels sprouts. They're just as good for vitamin C as oranges, although they never get listed. It's always the orange that's at the top of the list. Now let's ask a different question. Do we need vitamin C in our diet? I've already mentioned that vitamin C is important in our diet, but there's a catch here. People in Europe and North America tend to get too much vitamin C in their diet. What happens to the excess? Well, we pee it out, so it's a complete waste. Our bodies can't store vitamin C. So if you sit down and eat 20 oranges today, you're going to have a load of vitamin C, but it doesn't do you any good because it's just going to come out of your urine tomorrow. Vitamin C is one of those compounds where we need a little bit every day, but we don't need too much. So if you're living in North America, is vitamin C nutritious for us? Is it important to have it in our diet? And the answer is, well, no, it's not very important because we already get too much. So there's no point in telling people, well, eat more oranges because it gives you vitamin C, because people already have too much. Now, if you live in some third world countries, then vitamin C can be in short supply and it can be critical for your health. The sailors in Christopher Columbus's day found that out. So they would go on these long voyages and the sailors got scurvy. The reason they got scurvy was that they weren't getting enough vitamin C. They didn't know that at the time because vitamins hadn't been invented, but it was the lack of vitamin C that was making them sick and very sick. If your diet doesn't include enough, then vitamin C is a critical thing to have. If your diet already has a lot, you don't need any more. So when we come up with this nutrient density value, should we include vitamin C or not? Well, that really depends on where you live and what is your current diet. Another complication here is to get the data. So let's compare two fruits, the apple and the orange. Which one is more nutritious? Well, we really don't know. Now, partly we don't know because there is no nutrient density number for these kind of things. We also don't know because no one's gone and analyzed these two fruits for all 25,000 compounds. And even if they did, we have various varieties of oranges and varieties of apples, and they're grown in different regions and different countries, and they're all going to have slightly different nutritious value. They're going to have different nutrient density. So if you go to the supermarket and you have an orange in one hand and an apple in the other, and you ask the question, which one is more nutritious? Well, you don't know. You can't tell. And even in a lab, they would have a very hard time telling you that. So that complicates the whole story of what is nutritious. Now, as gardeners, we grow our own food, and we hope we're growing a lot of nutritious food. And I'm going to have a look at that subject matter in my next video, which is going to ask the question, how do we grow nutritious food? But for now, let's ask a slightly different question. How do I measure the nutrition in my food? Now, this could be food that you grow, or it could be food that you buy. Is there a way for us as gardeners or homeowners to go and measure nutrition? Well, there's some people running around who would like to convince you that there is such a thing. And this measurement is called Brix. Brix can be measured very easily with a little device, and you can go to Amazon, and for about $100 you can buy one of these Brix meters. It has a glass sheet. You put a drop of extract from your food, so a drop of orange juice or a drop of apple juice. You put that on there, close it, look through the lens, and there's a little scale inside, and you're able to measure the Brix value. So there's people running around and saying, well, geez, if you grow carrots and you grow two different types, you can check the juice of the carrots and tell which one is more nutritious. Higher Brix equals more nutritious, so they claim. Well, that's a complete myth. What Brix is a measure of everything in the liquid. So all the chemicals in the liquid. It's a sum of all of those. So it does measure vitamin C in a liquid, but it also measures 30,000 other compounds. It turns out that in most of our food, the chemical that is there the most, in the highest concentration, it's sugar. So we have a lot of sugar and a very, very tiny amount of vitamin C. Now, you could double the amount of vitamin C. It won't change the Brix reading because there's too much sugar. The one thing that does affect Brix reading is the amount of moisture in this food. So if we have a dry carrot and we have a more moist carrot, say it rained 3 days before we collected it, it has more moisture in it, then the one with the higher moisture value will have a lower Brix because the water dilutes the solutes that are in there. But the bottom line is that Brix measures sugar. That's it. It's useless for measuring nutrition. Now, laboratories are able to measure those 25,000 chemicals that we're interested in. So in theory, someone could take an apple and analyze all 25,000 chemicals and make up a big list and tell you what's in that apple. I don't even know if anyone's actually done that. We have done that for a shorter list of nutrients. So there's lots of studies out there that look at the minerals and the vitamins and even amino acids. And they might look at another 10 or 12 of these phytonutrients. But I don't know if a single source has gone out and looked at all 25,000 of them. The bottom line here is that we have a really hard time figuring out what is nutrition, and we don't really have any good way of measuring nutrition. We can't say that one food is more nutritious than a second food. We can, however, say that bananas have more phosphorus than, say, lettuce. But that's only one of the nutritious compounds that we're interested in. And if we have enough of that in our diet, we don't even care about phosphorus. The takeaway story here is that a lot of the headlines you see are not nearly as complete as you think they are. The whole subject of nutrition is much more complicated than you've been led to believe. If people online are telling you to garden a certain way for more nutritious food, it's probably a myth because they have no way of measuring their own food. If people are recommending one type of food over another or one type of cultivar over another, it's probably a myth too. So I hope you understand nutrition and nutrient density better, and that will help you become a better consumer of good food. Now, if you'd like to learn more about this topic, have a look at these videos right here. Happy gardening.